Hello, my name is Gianluca Mardente. I'm a principal engineer at Cisco Systems. I've been working on Kubernetes for the last 5 years. Today's talk is about Sveltos. Sveltos is an open source project that I developed which aims at simplifying Kubernetes addons distributions when you have tens of clusters. Today, it's very easy for an organization to have multiple clusters and to have those Kubernetes clusters in different cloud providers or infrastructures. And when you have that many clusters, consistently managing addons, it's not a very easy task. Sveltos is a lightweight application that can be installed in the management cluster and that can manage Kubernetes addons in any cluster that is directly reachable from the management cluster. Sveltos comes with built-in support for Cluster API. Cluster API is another open source project which is widely used to consistently create, upgrade, or delete Kubernetes clusters. Sveltos, as I mentioned, has built-in support for Cluster API, and that means that if Sveltos is installed in a management cluster where Cluster API is also present, no action needs to be taken. Sveltos can automatically detect any Cluster API powered cluster and manage Kubernetes addons in such cluster. But Sveltos is not limited to Cluster API. If you have a GK cluster, an EKS cluster, and you want Sveltos to manage addons in such clusters, you can easily register this cluster with Sveltos, and from that point on, Sveltos can seamlessly manage Kubernetes addons in any cluster. I'm not going into the detail of how to register a cluster with Sveltos. It's a very simple procedure which is listed in the Sveltos documentation. So please refer to that one. What I want to highlight here is that any cluster, it's represented in the management cluster. So Cluster API powered clusters are represented in the management cluster by the Cluster API cluster CRD. Any cluster which like GKE, which is registered with Sveltos, it's represented in management cluster by a Sveltos cluster CRD instance. So how does Sveltos solve this Kubernetes addons distribution? The idea is simple. Select a subset of the cluster that we manage and list the addons that we have to deploy in such clusters. In this example, I have a cluster profile instance. Cluster profile is one of the Sveltos CRDs. And the cluster profile spec section has two main sections. There is a cluster selector and there is an Helm chart section. The cluster selector, it's a pure Kubernetes label selector. In this case, this cluster profile, it's telling Sveltos to select any cluster that matches, that has the label environment production. And it is also, this cluster profile, it's also instructing Sveltos to deploy Caverno Helm chart version 2.5.0 in any such cluster. So what happens if we add the label environment production to the two workflow clusters that we have? Well, Sveltos automatically detects that those two clusters are a match for this cluster profile. And because this cluster profile is saying that the Caverno chart needs to be deployed, Sveltos automatically deploys Caverno in both clusters. Now, one thing which is important is that when you deploy an Helm chart or Kubernetes resource in many clusters, very likely you need to customize the Helm chart per clusters. For instance, if you are deploying Calico, you need to tell Calico what the pod sider is. In this example, I have a cluster profile which is instructing Sveltos to deploy Calico. And it's also instructing Sveltos to fetch the pod sider from the management cluster at runtime. Runtime means at the very exact time when Sveltos is deploying Calico in a cluster, fetch that information, and in this case, Sveltos is fetching that information reading the cluster instance that represents the cluster, and reading the spec, cluster networks, pods, CIDR blocks fields. Now, let's go back to the our example. We had Sveltos deploy Caverno in any cluster with label environment production. What happens if now one of the admin in one of the managed cluster deletes the Caverno deployment? So we have one of the admin issuing the kubectl delete deployment. And what happens is that Caverno gets deleted from the managed cluster. But if we do that now, we have a workload cluster state. It's different than the expected state. The expected state is what has been defined in the management cluster. The expected state for any cluster with label environment production says that Caverno needs to be present. As of now, Caverno has been deleted. So Sveltos has a configuration drift detection. Configuration drift detection means that there is an agent that Sveltos installs in each managed cluster, and this agent has one very simple role. Watch any resource which is deployed by Sveltos, and if this resource is modified, notify immediately Sveltos running the management cluster. In this example, Caverno was one of the resources that Sveltos deployed in the managed cluster, but this resource has been deleted by issuing a command kubectl delete directly in the managed cluster. So the agent running in this managed cluster automatically immediately detects that there is a potential configuration drift, and it informs Sveltos running in the management cluster. As soon as Sveltos is informed, Sveltos reconcile back, and by reconciling back, Caverno gets deployed back. When Caverno gets deployed back, the state of the workload cluster goes back in sync with the expected state defined in the management cluster. And there is absolutely no admin intervention that is needed. In all the examples we have considered so far, we had the management cluster admin set the labels on the clusters, but we are talking about managing tens, potentially hundreds of Kubernetes clusters. So we cannot expect the management cluster admin to be the only one in charge of setting the labels on each clusters. I wanted to have like a more intent-based mechanism. With that I mean that I wanted to be able to say if a cluster runtime state matches this, I want this set of labels to be automatically added to the cluster by Sveltos. Let's take an example. So we have a cluster profile, which we can ignore for now, and we have a classifier. Classifier, it's another Sveltos CRD. And this classifier in the spec section saying it has a Kubernetes version constraint, saying if you see a cluster running a Kubernetes version between 124 and strictly less than 125, such a cluster is a match for this classifier. And any cluster which is a match for this classifier needs to have these classifier labels added. In this case, the labels are simply gatekeeper B39. So let's see what happens in this example. We have two clusters whose version is 124.2. So they are both matching this classifier. And because they are both matching this classifier, Sveltos automatically adds the label gatekeeper B39 to both clusters. And when we use a classifier in combination with a cluster profile, because now those clusters have the label gatekeeper B39, they are a match for this cluster profile. And because they are a match for this cluster profile, gatekeeper gets deployed in the cluster. What happens now if we post another classifier instance? This classifier instance, it has a different Kubernetes version constraint, saying that any cluster running a Kubernetes version greater or equal than 125 is a match for this classifier. So what happens if we upgrade one of the clusters? If one of the clusters gets upgraded, it stops being a match for the old classifier and it starts being a match for the new classifier. Because a match for the new classifier, the labels is updated to gatekeeper B310. And because the label is updated, now the classifier matches different cluster profile. And because the classifier matches a different cluster profile, now a different version of gatekeeper is installed. So the gatekeeper gets upgraded from 390 to 310. So combining the classifier with a cluster profile, we can automatically have Sveltos update the cluster labels based on the cluster runtime state. And when the cluster labels change, the cluster stop matching cluster profiles, starts matching different cluster profiles. So the set of add-ons that gets deployed in the cluster change. Classifier, it's not limited to classify a cluster based on the Kubernetes version. You can classify a cluster based on any resource. There are many examples that you can refer to in the Sveltos documentation. Sveltos also has support to take snapshot. Snapshot is another Sveltos CRD, and in this case, this CRD, this snapshot instance, is instructing Sveltos to take snapshot every hour. When Sveltos takes snapshot, it takes like a snapshot of the configuration in the management cluster. Once you have like more than one snapshot, you can use Sveltos Gather, which is a CLI that I developed explicitly for Sveltos. And you can take a look at all that has changed between two snapshots. And if there is something that you don't like, Sveltos has also support for rolling back the configuration. So you can instruct Sveltos to say, you can tell Sveltos, bring the configuration back to this snapshot instance, and Sveltos is reconciling the management cluster configuration to the snapshot instance. Sveltos has many other features. Project Sveltos.io, it's the website with the full documentation, and there are many examples on how to register a cluster, how to classify a cluster based on resources on top of Kubernetes version. GitHub.com project Sveltos is where all these Sveltos repos are. And as I mentioned, Sveltos is an open source project. Any contribution is welcome. So if you have an idea, if you want to contribute, if you want to use it and you have like any question, please feel free to reach us on Slack, projectsveltos.slack.com. And I will be happy to hear from you. Thank you so much. Thank you for your time. I hope you found like this presentation useful. And again, I hope you find like the problem and the solution also a good solution. Thank you so much.